Yeah, hi. I don't have any animals in the presentation, but I think I also have one image that I think everyone was supposed to show in their presentation today. You'll see it later probably. So I'm... yeah, I have a very, well, rather applied background in design research in aerospace, human factors. And basically I look at human technology interaction in high reliability or safety critical domains, and spent the past 2 years doing a internal research fellowship at the European Space Agency based in their Space Operations Center, which is a large control center where they control satellite missions and unmanned probes. And when I got the invite for this symposium, I thought, well, the one thing that I can talk about would be live simulation in safety critical domains, so where people, either with computers or just people inside large simulators, simulate critical conditions and for research or training. And I went through the material of simulation case studies or anecdotes that I collected in the past 7 or 8 years, but I'm going to be looking through them or at them through the lens of a question that I've always wanted to ask, and or a question that I've been posing myself based on a quote from Sherry Turkle's book Simulation and Discontents, which is what simulation wants, and in my case what simulators want. And Sherry Turkle posed this question in the context of architectural computer-aided design and drawing and life sciences and genetic modeling. But she basically asked what simulation wants, or what it seems to want. And she offered that through our immersion, it's supposed to propose itself as a proxy for the real. But, she then went on, perhaps we could say without irony, it is what simulation really wants, not to replace the real, but to reveal it. And so I'm going to be looking at all these different kind of simulation anecdotes that I came across during work, or worked with, or worked on, or analyzed, to look at this kind of question: what does simulation want? And in my case, from a kind of design and architecture perspective, what do simulators, the environments, want? So I'm looking at large-scale socio-technical systems, which are basically large, complex systems in different safety-critical domains. For instance, aerospace, aviation, spaceflight, transport. If you look at the rail sector, defense and security environments, infrastructure, large, networks, utilities, energies, nuclear power plants. But also public health operations, biomedical laboratories, for instance, high security, pathogen units, but also complex science and engineering projects, so something like CERN this morning, which Sasha talked about a little bit. And these domains all have a number of characteristics in common, and these all make uncertainty even more challenging than it already is in these kind of settings. So they're all distributed in some form. They're never co-located. They're often very global. They have tons of different components. So we're actually not even talking about systems anymore, but systems of systems, or ultra-large scale systems. They're tightly coupled, which means that all the different components or parts that they have are highly interrelated and interdependent. They completely constitute each other, and they're highly complex. So they're extremely manifold, often diverse, and often very bespoke. They're often located or kind of situated in very hostile or geographically inaccessible environments. You can think of different pressures or radiation forces or temperature changes or light dark cycles in different environments, such as deep sea or space, orbit, the polar regions, or high altitude. And that means that these environments, if you think about human interaction in these settings, is often counterintuitive. So the environmental conditions are such that your normal experiences wouldn't necessarily give you any hint about how to proceed, or the kind of reactions that you would get from the settings. And even if you can't get into those environments, the interaction that you then have with it through computers, for instance, by steering a remote vehicle through these terrains, for instance, is completely virtual and often very abstract. So there's not necessarily direct feedback that you get back. If you think, for instance, about a Mars rover or something. And finally, these domains are subject to dynamic changes. The systems are so large and so complex that you can never really describe them completely at any point in time. They're changing all the time, and what happens can have huge reverberation and consequences that are not necessarily foreseeable, for a single operator, for instance. And that also means that the cost of failure, when it happens, can be extremely high. So, maybe it's a low risk of a large catastrophe, but when it happens, it's really, really significant. So, what are simulations, or what does simulation do in these kind of settings, or what is it used for? We can kind of group them on a very high level into three chunks, if you will, about the past, present, and future. So if you're looking at the near or midterm future, even the far future, you can use simulations for strategic thinking, to anticipate or to kind of challenge different kind of issues that are cropping up in the near or midterm future about something that you want to undertake or think about. If you're looking into the kind of near or a bit immediate future, then they serve for tactical rehearsal of plans, of procedures, of the different steps and protocols that you want to put in place or that you've designed to deal with in a certain environment, and to look at the different contingencies that you can explore for specific events that you've already decided you will be undertaking in this kind of setting. And also when you look at something in the past, if you want to revisit events that have happened, for instance, failures or something else that you want to reiterate and understand, simulators and simulations can offer you a way to re-experience or re-immerse yourselves into these settings and reflect on them, analyze them, and understand them a little bit better. So I'm going to now talk through an inventory of different kind of simulators that are used specifically in spaceflight, and crewed and uncrewed spaceflight. So if you think back about the strategic thinking about far-term futures or mid-term futures, you want to identify potential issues that can crop up. This is a image of the Concordia station in Antarctica, in the Dome Sea area, which is one of the most isolated places on Earth, and this is used. Antarctica generally functions as a kind of natural laboratory for behavioral research isolated in extreme environments for other isolated in extreme environments, for instance, for spaceflight. So this base, for instance, which is operated by, I think, the French and the Italian polar programs, is also used by space programs to place people there and to understand how they are coping in the long overwintering periods, for instance. So the people who spend 14 to 16 months there and overwinter an entire time, really get to experience similar conditions that, for instance, astronauts or cosmonauts would have on a long duration mission on different planet, for instance. But at the same time, their conditions are real. So although, they could believe, or they could immerse themselves in a setting to say that, okay, we feel like we're on the surface of a distant moon or a distant planet, they're actually in a realistically dangerous environment where they would not be able to survive if the power generator broke down, for instance. So it's acute. The danger is acute, although we're talking about an analogy. If you then want to place these kind of simulator environments not in an extreme environment themselves, but into a more controlled setting for research, then you would be constructing a simulator facility, such as this one at the Institute of Biomedical Problems in the Russian Academy of Science in Moscow, which hosted the Mars 500 study a few years ago, where 6 participants were placed in a simulator for 520 days to simulate a virtual mission to Mars. And this really served to, deepening the understanding about potential issues, but already knowing a little bit more about what these issues might be. So you could test different responses, you could test different technology applications that you've designed for them. Here you see 3 of the participants in their kitchen. And it's also like a sauna. So next time looks a little bit like one. So, in these kind of settings, you can really begin to put different technology applications in. This is maybe not that good of an example image because you see, microwaves and so forth, but you know, there are different countermeasures or prototypes that can be tested in these settings. Then to go a little bit more conceptual again, or if you want to combine these kind of simulator environments, or live simulation environments with virtual technology, you could be fusing different kinds of human behavior and performance issues with different prototypes that you want to test that are not necessarily so clearly sketched yet. This is a mock-up of an asteroid habitat based in the giant mock-up hall at NASA Johnson Space Center in Houston, Texas. And basically, I don't know if you can see it on the right, there's a kind of little phalanx of screens in which you can plug in different kinds of simulations. So this is then linked, for instance, to the virtual reality lab, where usually astronauts can be trained. Can you see? Yeah. Where astronauts are trained to conduct extravehicular activities or spacewalks. Basically, you can sit it's actually almost like a normal office chair, but you're rigged into a virtual reality system. You have very simple but effective load-bearing devices to mimic mass and so forth. But what you're seeing and what you're immersing yourself into would be what you can see this little this person there seeing. So you can immerse yourself in a different setting and start performing the small narratives of, you know, walking around, looking at rocks, for instance, that are even more rocks. It's also a theme, but... And this is the picture that I think mimicked exactly what you were saying. You know, if you then want to take these narratives and you know exactly what you want to be doing in certain types of setting, you can then simulate them with all the gear, with all the technology that you have, without going into the actual environment. You can still already rehearse you know, the different steps and test your equipment and troubleshoot activities or learn them when they're really critical. And that was, you know, exactly these critical setting activities that Sasha was showing, and I think you also showed an image of setting up the tripods, grabbing stones and rocks on the surface of the moon. This is, was a simulation during the Apollo program with Pete Conrad and Alan Bean before they flew. And you can also then hook up these kind of technologies to all the different other constituent elements that are part of such an operation. For instance, the control teams on the ground or outside the environment that you're dealing with. In this case, for instance, this is a simulation suit developed by the Austrian Space Forum, which they've tested so far in a number of settings, such as glaciers, caves, deserts, snow mountains, and they use this to really look at improve the way different teams work together when one person's executing a you know, activity such as a spacewalk. Then simulators or simulated settings can help people to familiarize themselves with a novel environment, even though they cannot access it yet. So, for instance, you may know parabolic flights, where a plane flies a parabola and you get these small chunks of time with reduced gravity conditions. So although you can't really mimic microgravity on the ground, if you want to start exposing yourself to it, you want to learn about the counterintuitiveness that I talked about earlier, and start developing automatic responses, for instance, of moving about in these settings, then you would be, you know, testing this or rehearsing this in another setting. For instance, these parabolic flights in large planes. And the same thing, if you then want to go through a critical task again with all the gear that you have, when you know much more about what's going to happen, you can mimic the same conditions in another setting, such as a neutral buoyancy facility, which is a large tank. In this case, it's one based in Cologne at the European Space Agency, which basically, where you have buoyancy, and that mimics conditions of reduced gravity, and you can start learning critical tasks and really train for these kind of things and become confident in dealing with them. But also in the, I mean, these were all examples from crewed spaceflight, you know, where you have one person or a small team of people going into an extreme setting. But the majority of spaceflight, of course, is satellites or unmanned probes that are controlled by large teams or flight control teams. that come together, and especially before launch operations or critical or special operations, these teams come together. There's a bigger control room for them, and they all start, planning, or not planning, but they start rehearsing and going through the different plans that they've put together, troubleshooting procedures that they're going to be using during this operation, such as a launch, and also refining the system that they're going to be using, refining different protocols that they use, and learning more about the system that they're going to be using at the same time. And the last example I want to show is also from the unmanned spaceflight example, when simulation is used not before an event to train for it, and not necessarily afterwards to understand something, but during actual operations in order to test something, or in this case to avoid a sense of hubris or complacency when things are normally going right all the time. In this case, this was the Chandra X mission, or is still, and there was a really interesting paper like a few years ago about a surprise simulation that had been conducted with the flight control team, who was manning the control room, and this was organized by mission management, and the flight controllers didn't know, but management injected an anomaly. They planned it all beforehand, injected an anomaly into the control system, or at least into the data that they were getting, so that the team had to react as though a real emergency was happening, because usually the mission was running like textbook. And that really helped them to, even after a long time of operating successfully, to probe the different kind of mechanisms or measures that they have in place for distributed decision-making, of integrating different stakeholders that they deal with, information that they have to get from other centers, people have to come in from their on-call shifts and so forth. So they have to kind of rehearse the exact same thing that they would be doing before they do a special operation, but it's used during actual operations, and they think they're actually operating a real emergency. Interesting question there, but that's actually, we can talk about this later. And so basically, if we summarize or synthesize the different themes that all of these different types of simulators do, or what they reveal, or what they afford actually, is something that they, and they each only simulate a chunk of a reality that you want to be dealing with in the future. So none of them really show you the entire experience or the entire environment. They always mimic chunks of it. They enable you to discover contingencies, or to identify different contingency operations in these kind of settings. They enable operators to develop heuristics, or rules of thumb that they, especially in very highly rigid settings where normally everything is governed by a procedure, but when a procedure or plan isn't compatible with the situation as it has emerged anymore, then you would be, you need to rely on your instinct in order to kick off troubleshooting. They entice you to exercise caution and to cultivate a sense of humbleness in front of, or before this kind of very, before a uncertain environment. So what I want to say is essentially that on the one hand, simulation gives you the scope to acquire confidence in a very, very safe setting, but on the other hand, it also allows you to become humble and to understand that failure can happen, for instance, and that you don't develop a sense of hubris, of knowing exactly what's going to happen, because you've made all the plans and you've rehearsed very well. So I think if we want to ask what simulators want, if we return to this original question, in view of uncertainty, then it's a reduction of uncertainty on the one hand, because you're reducing the unknowns, if you will, to an extent, but at the same time you're developing a kind of respect for this uncertainty. And I think this is what simulators, if they were entities, which they are not, unless you're talking about agent-based modeling maybe, I think this is maybe what they want. And with this, I'm done, and I think maybe we can have questions or end the discussion later on anyway. Thank you.